And from the first year of a 3-year study, we showed that the organic grower could produce as much, and in some years more, return on investment as the conventional system. And when that started to happen, the conventional strawberry industry accused us of falsifying our data. And it took us 5 years to finally get it published in the conventional journals. Well, you keep at it. That resistance that I talked about a little bit in that article that I had you all read. And then thinking about what strawberries could look like with this approach. A complex system of rotations and crop associations. Not strawberries year after year after year that fumigation allows, but a rotational system. The way strawberries were grown before, methyl bromide was developed for fumigation. And relearning how to do rotations and which ones work and how you can make sure they work using the science and the practice coming together, embedded in a natural landscape where nature is part of the system as well. And out of that experience, we developed this protocol for the study of systems in transition, thinking about level 1, which is where I think many agronomy schools might still be stuck, but they certainly were completely in this area when we started our conversion studies in 1985. Taking conventional practices and, yes, trying to improve them, cutting costs, maybe lessening environmental damage, but it's still a conventional approach, and it's usually a monoculture approach. With our strawberry grower in Santa Cruz, we developed level 2, where the idea, of course, was to substitute conventional inputs and practices with alternatives. Alternatives, in this case, which met organic certification standards. And that gave us a pretty important goal to shoot for. And we got to a point where, yeah, you could take out chemical fertilizers and put in compost, but it's not the same. It stimulates a whole different set of interactions at the soil level. And you have to learn how to manage them and deal with them and understand them, especially after a couple of years of strawberries. And what are your indicators to tell you that it's time to move into another crop, and which crop? All kinds of stuff. And we reached a point where, though, at level 2, the system design hadn't changed. It was still monoculture strawberries. And problems that presented themselves in level 1 also presented themselves in level 2, and oftentimes more intensely because you didn't have the same type of input to control them. So this is what led us into level 3. Redesign the system using ecological concepts and principles so that the system itself resisted the problems. And that's where diversification, rotation, just a whole set of different interactions became part of the management. And then thinking in different systems around the world where this approach could be used and is being used. Olives in southern Spain, monoculture, dry farmed olives, compared to a place in Italy where the traditional practice is olives, grapes, and in between, usually in the spring, oats or wheat. Gosh, think about it. There you've got your bread, your olive oil, and your wine. What else do you need? Coffee. Huh? Maybe. Or rice, which can be grown in large-scale monocultures, in this case in southern Brazil, compared to the traditional Chinese rice system with a fish pond and rice paddies and vegetables and a rotation between all three of those that takes place over time, and a home garden system with a diverse set of perennial crops. Some of them, for example, silkworms being grown on mulberries, and the waste from the silkworms going into the fish pond. And all these parts are connected. And the question is, why this when we know this is an option? Or it was for such a long time? What drives that change? Or coffee, get back to that. You know, where so much of the coffee, remember, is a plant that evolved in the shade of trees and forests in the mountains of Ethiopia. And now it's being grown in full sun in southern Brazil. Yet small growers have learned how to kind of simulate, using nature as their model, you know, growing coffee in the shade and diversifying that shade. So it's not only producing shade, it's producing food, it's producing organic matter, it's producing firewood, it's producing medicinal plants, a whole lot of different things. And I remember when the farmer on the right there, Don Roberto, told me one day, you know, if I could get more money for my coffee, I could plant less coffee. And I could plant the things that my farm needs and my family needs, and I could sell locally in my community, and I wouldn't be so dependent on coffee. Well, that gave me a lot to think about. Again, that learning from other sources of knowledge. and developing in the process of this conversion indicators of sustainability to tell us if we're moving in the right direction. And the first 4 here are ecological indicators. And we have tools in ecology for measuring most of these, from soil quality to indices of diversity. The last 3, though, economic, social, and cultural resources as indicators, those are a little more complex. Econometrics gives you some way of evaluating if you're getting a return on your investment, but then there's ecological economics, externalities, return on investment that's different. And then social resources. What are your indicators of a healthy society connected to food? And how is that connected to a cultural process of learning and sharing and passing on that knowledge? So I remember when Charles Francis and a group of us, we put out this little paper called Agroecology, the Ecology of Food Systems. And it really pushed me away from just using the term agroecosystem, which a lot of people just think is an ecological term. And that even though I mentioned that people were the complicating factor in agroecosystems, agroecosystem as a term didn't really get people thinking beyond the farm. And that's when we started thinking about the whole food system. The food system, from the seed and the soil all the way to the table and back again. A whole system, and understanding what drives that system, using an ecological perspective of interrelationships and interactions and feedbacks and all that to really move on. And it made me look at the strawberries in a little different area. This is only up to 2003 on this map, a number of acres of organic strawberries. We started our study back in 1985, it was 0. And look at it, 1997 it was only 134 acres. Well, in 2011, the last data that I have, it's 1,638 acres. But this is the piece that really made me think about the fact that number of growers increased. Probably was 1 or 2 back in 2000 or back in 1985, up to 119 in 2000, and started dropping. And by 2011, it was down to 95. And I think in the present, it's probably dropped even a little more. What's that tell you? Fewer growers, more acres. It's being concentrated in fewer hands. And there's a whole set of likely players in that process that I won't go into. But they're usually the big scale, vertically integrated organizations that control the strawberry market. So that led us into the second edition of the book, came out in 2007, with a different subtitle, The Ecology of Sustainable Food Systems. And the cover now, still got the corn, beans, and squash down here on the right, but it's got people in it at the market. It's got animals in it. It's got small-scale agriculture. It's got larger-scale agriculture, giving us a whole different way of thinking about the food system. And we added another level to that conversion process, that transformation process, one that focuses on the 2 most important parts of the food system, in my opinion, the people who grow the food and the people who eat the food, who for so long have been so separated and isolated from one another, they don't have the slightest idea where the eaters, for example, where the food comes from, how it was grown, or anything else. And the producers, the growers, they don't know where it goes. You know, they've been completely separated. And the idea of this level 4 is to reconnect those 2 in a relationship-based food system, marketing system, where there's a whole different way of developing alternative food networks. And you've seen it, you're doing it. Direct markets such as farmers markets, CSAs, the whole local agriculture or relocalization movement, I like to call it. The development of food hubs that aggregate food from small farmers and then redistribute it directly to consumers. And the whole idea of urban and peri-urban agriculture, bringing home the process of growing, processing, and consuming food. So that rather than just thinking about the price on the market, we look at what's behind the product. Who grew it? How did they grow it? How does making the choice to buy from that farmer, be it he or she, make a difference for them? And I think you probably heard about that a little bit from the last 2 sessions of how important that relationship is for the success of small farms. And we see it in lots of parts of the world. A farmer's market in southern Mexico with a family at the stand selling things that all came out of their home garden system. Or farmers markets, this one in Santa Cruz. And Santa Cruz now has at least one, sometimes two farmers markets every day of the week. And they've just exploded. And yet, not enough people go to them when you think about how many people are eaters. Or one like this in southern Brazil, which kind of helps farmers in the sense it's farmers' organizations. Small farmers form small associations of 15, 16, 17 farmers. So a farmer doesn't have to go to the market every time.